Hello, and welcome to another episode of Math Made Easy by Mrs. Roberts. In this mini-series, we are going to try to tackle a very difficult concept called trig substitution in calculus. So this is going to be a very basic introduction, and in this introduction, I just want us to start beginning to think about why. So we're going to be looking specifically at these rules here, 18, 19, and 20. And as of right now, we know that if we see something in this form, we're going to apply this arcsine rule or this arctangent rule or this arcsecant rule. But I want us to think about why. And so that's what we are going to tackle today, is the why behind those rules. So I want us to begin by drawing a right triangle. So let's go ahead and draw a right triangle. And we're going to say this is the right piece of it. And this is our angle in question. And we'll call that angle theta. Now, previously, so in pre-calc, we had what we called the UV coordinate system. And so we had that axis and we had this axis, right? And so now what I would like us to do is I would like us just to start naming some pieces of this. Let's say that this is U. And let's say this is A. And let's say those two things are given. U and A are given. And if U and A are given, could we figure out this side? Well, this is a right triangle. We can use Pythagorean Theorem, and Pythagorean Theorem says this side squared plus this side squared equals this side squared. So this side squared plus this side squared equals this side squared. So what we know is this side right here, we'll call him line. Line squared plus U squared equals A squared. Well, I want to get this line squared by itself. So I'm going to subtract U squared from both sides, and I'm going to get line squared equals A squared minus U squared. And then to figure out what this side is, I'll take the square root. And really, we are only worried about the principal square root, the positive piece of the square root right now. And so this side right here is actually the square root of A squared minus U squared. Okay, so we were able to draw this triangle out, and right now we've just kind of labeled some things, some things, okay? So we labeled this U, we labeled this A, and then we were able to figure this out. Well, if this is our theta in question, we could say that sine of theta equals U over A. That's true. And therefore, we could say that U equals A sine of theta. That's true. So we've got a couple of different things here. We can say that U is A sine of theta, which means now I could put things in terms of theta. And that would be like this. I could say that this is the same thing as the square root of A squared minus A sine of theta squared. But we can do some algebra on that. And the algebra on that would say, okay, well, this is actually the square root of A squared times 1 minus sine squared. And 1 minus sine squared is cosine squared. And so this actually becomes A squared cosine squared of theta. And I can take the square root of that. The square root of that is A cosine of theta, which means that this right here is actually just A cosine of theta, which means that this right here is really just A cosine of theta. which means that if I were to start redrawing this triangle, I could label that side A cosine of theta. This allows us to start using more basic trig to then solve for these more complicated integrals. So that is kind of where some of these things are coming from. And so over here, you're going to see these are our rules for trig substitution. And what we just did together was we just figured out what the heck one means and why. So for integrals involving the square root of a squared minus u squared, which is this piece here, and that was derived using the Pythagorean theorem, the square root of a squared minus u squared plus u squared equals a. So using that, we can say that u is a sine of theta, and we can say that because of this piece here, okay? And then if that's true, if u is a sine of theta, then all of this becomes a cosine of theta because of algebra. Because when we substitute in a sine of theta, because we know that u is the same thing as a sine of theta, then this becomes a squared times sine squared, and then we can substitute it in a Pythagorean identity, and then we can simplify it to a cosine of theta. And so we can say right here that the square root of a squared minus u squared is a cosine of theta. Now, we could spend time deriving 2 and 3 and why those work. But instead, I would like you guys to do that. I would like you guys to draw a triangle that would match up with this. Remember, a plus sign in between means that now this is our C value. This is the hypotenuse, okay? And so go ahead and try this out for those other triangles and see if you can figure out where is all this stuff coming from.